Hello students, welcome to Alle Scholar classes. So today I will be taking chapter 4, that is carbon and its compound, from 10th class science, CBSE science. Okay. So if we talk about carbon, the first thing that comes in our mind is that if you remember the objects which you come across daily in your life, okay, per day, सुबह मॉर्निंग से लेके आप नाइट तक किन किन चीजों के अक्रॉस आते हैं. वी टॉक अबाउट इन द मॉर्निंग वी ब्रश आवर टीथ. व्हाट वी यूज टूथपेस्ट. ओके, देन वी हैव आवर ब्रेकफास्ट. ओके, इन ब्रेकफास्ट वी टेक सम ब्रेड और समथिंग. देन वी स्टडी, वी यूज आवर बुक्स. We take bath, we wear clothes. If we are ill, we take medicines. Okay? So, and we wear shoes. So like this, there are thousands of things which we come across in our daily life. Okay? Day to day, daily. So these compounds, or you can say these items, what are they? They all are made up of carbon. Toothpaste is having carbon. If you eat something, that food is having carbon. Book spaces are made up of carbon. Our clothes have carbon. Medicines have carbon. Shoes has carbon. So we can say that in our day-to-day life, daily life, we come across carbon at each moment. Okay? So कार्बन हर टाइम पे हमारे साथ होता है या हमें हमेशा कार्बन की जरूरत पड़ती है. सो नाउ यू कैन अंडरस्टैंड दैट हाउ एसेंशियल एंड हाउ इम्पोर्टेंट कार्बन इज. ओके, सो लेट्स सी सम ऑफ द बेसिक थिंग्स अबाउट कार्बन. सो इफ वी टॉक अबाउट कार्बन इज द fourth abundant substance in the universe. It is the fourth abundant substance in the universe. Fourth abundant substance in the universe. Okay? And it is the 15th most abundant substance. 15th most abundant substance in the earth crust. In which ratio we are talking? In the earth crust. Fine. So the earth crust, if we talk about the percent of carbon present in the earth crust is 0.02%. Okay, 0.02% carbons are present in earth crust in the form of minerals. How they are present? In the form of minerals. Okay, so now these minerals can be in which form? They can be in the form of carbonates, hydrogen carbonates, coal is there, petroleum is there, petrol is there. So all these present in the earth crust are how many %? 0.02% form of minerals. In the form of minerals, carbon is present. Okay? So it can be anything of this. So now if we talk about the amount of carbon present in the atmosphere, it is how much? 0.03% of carbon present in the atmosphere of carbon dioxide, CO2. Okay? So in spite of this small availability of carbon, you can see this ratio, this percentage is very less. This percentage is also very less. So it means the carbon is present in very small amount. Okay, Carbon is very important. It is just full of, you can say, very beneficial. It is very full of lots of importance are there. So if we talk about bonding in carbon, the carbons have which type of bonding? They have covalent bond. Okay. So in our previous chapter in metals, we have studied that metals have which type of bond? They were bonded by ionic bond. Okay. So these carbon, they have covalent bond. They don't have ionic bond like metals. So now we will see the features of their covalent bond. If we see these covalent bonds, so these covalent bonds are very tightly bound. They are. Okay. So what happens? These electrons are not free. They are not free to move for conduction of electricity. So carbon is a covalent bond and is a poor conductor of electricity. Okay. So carbon compounds are mostly poor conductor of electricity. Now if we talk about the boiling and melting point of these carbons, then the boiling and melting point of carbon is very low. Okay. So if you remember about metals, they were having very high melting and boiling points. So we have seen in these metals that the boiling point was so high, melting and boiling point, they were about 1000 or more than 1000. But in case of carbons, the boiling and melting point is very low. Okay. So let's see some of the examples of some of the carbon compounds which have a very low melting point. So if we talk about acetic acid, the melting point of acetic acid is 290. So here you can see it is very low melting point, and the boiling point of acetic acid is 391. Again it is very low, and we have seen in case of metals it was about 1000 the melting points and the boiling points were greater than 1500 for all the metals. But in this case it is very low, as we have seen the example of acetic acid, and some other examples are like chloroform. Okay, if we talk about chloroform, the chloroform have melting point 209. It is again very low, and the boiling point is 334. That is also low. Okay, so other examples are like ethanol is there. It is also a form of carbon. It is also a carbon compound which is having how much boiling point? 156. It is very low, and the melting point is 156, very low, and the boiling point is 351. Again it is low. And if we talk about a very common carbon compound, that is a methane. Methane has got how much melting point? 90. You can imagine how low this is, and the boiling point is 111. It is again low. So we got to know that the boiling point and the melting point of carbon and its compound is very low, whereas as we have read in metals, these were very high. Okay. So now what happens, since these are very poor conductor of electricity, so the force of attraction between the molecules are not very strong. Okay, since these compounds are largely non-conductor of electricity, the bonding in these compounds does not give rise to electricity. Okay. So now we will see the electronic configuration. Okay. Electronic configuration of carbon. Okay. So if we talk about the atomic number of carbon, the atomic number of carbon is 6. Atomic number of carbon is 6. Okay. Means the number of protons present in carbon is 6 and number of electrons present is 6. Okay. So let's fill the cells. So in the first cell there will be 2 electrons. In the next cell there are 4 electrons. So it means these 4 electrons, they are free. The valence cell is not complete. Now to complete this valence cell, what is required? Either it is going to take 4 more electrons, then 8 electrons in the valence cell, or if it donates its 4 electrons, so then this cell will be removed and the first cell is going to have 2 electrons. Then it is going to complete its octet. So what is the requirement? Either this carbon gives its 4 electron to complete its octet, or it takes 4 electrons from some element to complete its octet. Okay, so in case of carbon, as you are seeing, the 4 electrons that are present in the outermost cell are need to be gained or lost. Okay, more 4 to be gained or more 4 to be lost. कार्बन को या तो ये 4 इलेक्ट्रॉन अपने किसी को देने होंगे जिससे कि ये 2 आ जाए इसके ऑक्टेट सेल को कंप्लीट करने के लिए, वैलेंस सेल को कंप्लीट करने के लिए, हीलियम और नोबल गैस इट इज उसको अटेन कर ले, या तो ये 4 और ले ले. ओके, जिससे कि ये 8 इलेक्ट्रॉन्स कंप्लीट कर ले, अपने ऑक्टेट को कंप्लीट कर ले अपने वैलेंस सेल के लिए. तो या तो ये दे दे अपने 4 इलेक्ट्रॉन या ले ले, जिससे कि इसके पास नोबल गैस का कॉन्फ़िगरेशन हो जाए, so that it can attain a noble gas configuration. So let's see if it loses its electron, what is going to happen, and if it gains its electron, what is going to happen. So it could, if it is going to gain 4 electrons, it is going to form C carbon 4 negative. Okay, since it is gaining electrons, so 4 negative charge means 4 electrons are getting added, 4 negative charges are getting added, 4 negative, C4 negative ion. Okay, but what is going to happen if this is being formed? It is referred for the nucleus with the 6 proton, as it is having how many protons? 6 proton. So if it is going to gain 4 electrons from other compound or other element, so it will be difficult for this 6 proton to hold on 10 electrons. Okay? Are you getting this? अब क्या होगा अगर ये 4 इलेक्ट्रॉन लेता है तो the proton of electrons. Okay, the protons cannot hold this extra electrons. Fine. Achha, now in other case, if suppose it is going to lose its 4 electron. Okay, if it is going to lose its 4 electron, then C4 negative cation is going to be formed. Since it is losing its 4 electron, means 4 negative हट रहे हैं तो 4 positive आ गए. So now in this case, what is going to happen? इस 4 electrons को निकालने के लिए, since they are a huge number of electrons, so much of energy is required. Huge amount of energy is required to remove this 4 electrons. Okay? So what is going to happen? This proton again cannot hold. Again, it will be very problematic because large amount of energy is being required, leaving behind a carbon cation with 6 proton, and its nucleus is again going to have how many electrons? In this case, the proton will be 6, and since it has donated its 4 electron, so the electron is going to be 2. So again it is going to be a problematic. So it means कि carbon can neither take an electron or not give. मतलब कि carbon ना तो अपना ये 4 electron दे सकता है, नहीं तो 4 electron ले सकता है. In the both cases you have seen it is going to have lots of problem. So now what carbon can do? Okay. So to overcome with this problem, carbon shares its electron. ये जो 4 इलेक्ट्रॉन हैं कार्बन के, ये किसी ऐसे एलिमेंट के साथ शेयर करेगा जिससे कि इसकी वैलेंसी भी कंप्लीट हो जाए, वैलेंस सेल्स भी कंप्लीट हो जाए, it can complete its octet, and there can be a bonding also. Okay, so to overcome this problem, the carbon shares its valence electron with other atoms or carbons or atoms of other elements, and such sharing of atoms, electrons of atoms is which type of bond? Covalent bond. So we have studied in ionic bond. In case of metals, the ions, the electrons were transferred or taken. Give and take process था वहाँ पे. Okay, so that was the ionic bond. But in case of covalent bond, sharing is there. So the shared electrons belong to the outermost cell of the atoms, and that lead to both atoms attaining noble gas configuration. अब ये कार्बन जिसके भी साथ शेयर करेगा अपने इलेक्ट्रॉन्स को, तो इसके भी आउटरमोस्ट में इलेक्ट्रॉनिक कॉन्फ़िगरेशन वैलेंस सेल का होगा, और जिसके साथ शेयर किया उसका भी कंप्लीट ऑक्टेट हो जाएगा. ओके, सो देयर इज नो अदर ऑप्शन एक्सेप्ट शेयरिंग, एंड दिस टाइप ऑफ शेयरिंग इज कॉल्ड एज कोवैलेंट बॉन्ड. ओके, so we got to know that. We will be taking some of the examples how sharing of electrons is being done. So the first very example is of hydrogen. These hydrogen atoms are bonded in a form. Okay, one hydrogen is bounded with other hydrogen to form a covalent bond, because again they share their electrons equally. They can't take. हाइड्रोजन के पास भी एक है इलेक्ट्रॉन, इसके पास भी एक है. अब ये ना तो ले सकता है ना दे सकता है, तो ये वाला हाइड्रोजन अपना एक इसके साथ शेयर कर देगा, ये इसके साथ, तो इसके पास भी 2 हो जाएंगे, इसके पास भी 2 हो जाएंगे. और ये लोग कौन से नोबल गैस? हीलियम जो नोबल गैस है उसके इलेक्ट्रॉनिक कॉन्फ़िगरेशन को कवर करेंगे. ओके, सो दे आर गोइंग टू share it equally. So covalent bond formed between non-metal atoms, okay, that share similar electronegative values. Okay, so hydrogen, in case of hydrogen atom, can form covalent bond will be between them. So we all know that hydrogen is the simplest molecule. Okay, it is the simplest molecule. So the atomic number of hydrogen is 1. Atomic number of hydrogen is 1. So now how can atom share itself? So the atom has 1 in atomic number. So K cell में 8. अब क्या करना है? It requires 1 more electron. एक और इलेक्ट्रॉन अगर इसको मिल जाएगा तो it is going to be 2 and it can fulfill its K cell. ठीक है, अपने K cell को ये भर लेगा. So 2 hydrogen atoms are going to share their electrons one by one. Okay, so we will see how this sharing is being done. So suppose this is an hydrogen atom. This is 1 electron of this hydrogen and this is another electron, 1 electron of that hydrogen. So what they are going to do, these are hydrogen atoms. Okay, okay, so now we will see how the sharing is done. In maths we must have studied about Venn diagram, so we will be making like a Venn diagram. So this is 1 hydrogen, this is other. Okay, hydrogen 1, hydrogen 2. I just suppose this is, so hydrogen 1 का electron यहाँ है और hydrogen 2 का. So both the electrons are sharing, now getting how many electrons? 2 electrons in their K cell. That is, they are going to fulfill which noble gas? Helium. Their valence is now complete. So this is what? This is H2 molecule. Okay, this is a H2 molecule and the bond is formed, 1 covalent bond between both. H के बीच में कितना covalent bond है? 1 covalent bond is there. H is having single bond between 2 hydrogen atoms. Okay, so this was all for this. Keep this as if they share it like this allows the hydrogen atom to attain the electronic configuration of the nearest noble gas, that is a helium gas, and the shared pair of electron is said to constitute a single bond between 2 hydrogen atoms, and that is a covalent bond, single covalent bond. So we have seen the covalent bonding between hydrogen molecules. 2 hydrogen, they were having a single covalent bond when they form a covalent bond. Okay, so these was the hydrogen and hydrogen, same type of, these 2 atoms are of same element. Okay, this is also hydrogen, this is also hydrogen. So this type of atom is called as diatomic. Okay, what is diatomic? Diatomic means there are 2 atoms of a same element. So similarly, now we will see the covalent bond formation between chlorine atoms, Cl2, 2 chlorine. So they are also diatomic because chlorine and chlorine, same atom of a same element. Okay, so it is also diatomic. Okay, so if you remember, the atomic number of chlorine is how much? It's 17. Okay, so let's make the electronic configuration. 2, 8, 8 to 10. So how many left? 7. So in the outermost cell it is going to be 7. So now how many electrons does this chlorine requires to complete its octet? It needs only 1 electron. 1 electron, अगर एक इलेक्ट्रॉन इसको मिल जाएगा तो 2, 8, 8 कॉन्फ़िगरेशन हो जाएगा जो कि एक नोबल गैस का कॉन्फ़िगरेशन होता है. Okay, so now what it is going to? It is going to share an electron with this chlorine is going to share with this, and this chlorine is going to share with this. Okay, they are not neither going to take an electron nor they are going to give an electron. They are going to have a share. So let's see, two chlorine molecule are there. Okay, one is here and the other is here. So in the outermost cell, 7 are there. So 1, 2, 3, 4, 5, 6 will remain here, and one is going to be shared with the other chlorine. Similarly, in this case, 1, 2, 3, 4, 5, 6. Okay, and the one is going to be shared. So now this chlorine is also having 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outermost cell. This chlorine is also having 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outermost cell. So the octet has been obtained. So this Cl and Cl between the two Cl is again having a covalent bond. So we have taken the example of two molecules, hydrogen. Here also single bond was there, and in chlorine also there was a single bond between both the hydrogens. Okay. So now what we have to do? We will now pick some examples in which there is a double bond. Okay, not a single bond, but there is a double bond between two electrons. Between two atoms. So second we have seen of chlorine. Now third I am going to take for oxygen. Let's see what happens when these oxygens share their electrons. Okay. So now let's talk about third is oxygen. So if you remember the atomic number of oxygen, how much it is? The atomic number is 8. Okay. So it means that if you make the electronic configuration 2 in the first cell and 6, 2, 6, 8 means it needs 2 electrons to be added so that it can complete its octet. So now what? These 2 oxygen means O2. 2 oxygen are going to share. So here you can see this is one oxygen and this is a other oxygen. Okay. So how many electrons are there in the outermost cell? 6 are there. So 1, 2, 3 and 4 will be here, and 2 are going to be shared. Okay, similarly in this 1, 2, 3 and 4 here, and 2 are going to be shared. So this oxygen is sharing 2 electrons with this oxygen, and this is sharing 2 with this. So now you counted number of electrons 1, 2, 3, 4, 5, 6, 7, 8. For this oxygen 1, 2, 3, 4, 5, 6, 7, 8. So it has completed its 8 octet. But they have shared how many electrons? 2. So the bonding between 2 oxygen will be double bond. Here hydrogen was having single bond, chlorine was also having single bond. But if we talk about oxygen, they have which bond? Double bond, double covalent bond. So in case of oxygen, as you have seen here, we see a formation of double bond between 2 oxygen atoms. This is because, why this is happening? This is because 6 electrons are there in the L cell. This is the suppose K cell, this is L cell. So 6 electrons are there in the K cell. So it requires how many electrons? It requires 2 electrons to complete its octet. So each of the oxygen atom is going to share it 2 electrons to just complete its octet. So the shared electrons. So this type of bonding is called as double bond between these two atoms. Okay. So we have seen for hydrogen, chlorine and oxygen. Now the fourth example or fourth type of bonding we will see between nitrogen and 2. Okay. So if you remember about the atomic number of nitrogen, it is 7. Okay. Atomic number of nitrogen is 7. So if you make the electronic configuration 2 and 5. 2, 5, 5, 6, 7. So how many electrons it needs? It needs 3 electrons to complete its octet. Okay? To complete its octet, it needs 3 electrons. So what it is going to do again? 2 nitrogens are going to share their 3 electrons with each other. So here nitrogen 1 and the, sorry, I will make it little bigger. So this is N1 and this is N2. Okay. Fine. So how many electrons? 5 are there in the outermost cell. So 1 and 2 they are going to have. 1 and 2 and 3 of suppose this is a circle. Okay, this one is a circle. So 2 is there and 3 they are going to share. 1, 2 and 3. 1, 2 and 3. So let's count the number of electrons in the outermost cell. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This means that both the nitrogens have completed their octet by gaining 3 electrons. So now, how many sharing is there between 2 nitrogen? 1 electron, 2 electron and 3 electron. So which type of covalent bond is this? This is a triple bond. Okay. So oxygen was having double, chlorine and hydrogen were having single bond. Nitrogen is having which type of bond? Triple bond. And these all are the examples of diatomic. Means both the atoms are same. Hydrogen, hydrogen, chlorine, chlorine, oxygen, oxygen, nitrogen, nitrogen. Now we will be taking an example in which the diatomic element is not there. Okay. So now let's see. So now we will see for fifth is for methane, that is CH4. Okay. So we have already studied that it has how many? Each hydrogen has 1 electron in its outermost cell and the carbon electronic configuration is 6. Atomic number of carbon is 6, means 2 and 4. It needs how many electrons? 4 electrons to complete its cells. Each hydrogen has how many electrons? What is the atomic configuration? 1. So it is having 1. So now see how this carbon and hydrogen are going to share. Suppose this is C, 1 hydrogen, okay, 2 hydrogen, 3 hydrogen, and this is excuse me, 4 hydrogen. Okay, hydrogen 1, 2, 3 and 4. So we all know that chlorine has 4 electrons in its outermost cell and all these 4 it is going to share. It is going to share 1 with this hydrogen, 1 with this, 1 with this and 1 with this hydrogen. Okay. So this hydrogen is having 1 electron, it is going to share with this carbon. So and this hydrogen is having again 1 electron, this hydrogen is again having one electron, it is going to share with this carbon. This hydrogen is again having one electron, so it is going to share with this. So if you see for hydrogen, all the hydrogens are having how many electrons now? 1, 2, 1, 2, 1, 2, 1, 2. Means the hydrogen has attained how many electrons in the outermost shell now? 2. It has completed its valence shell and to the nearest noble gas, that is helium. And now if you see about carbon, carbon is having how many electrons? 1, 2, 3, 4, 5, 6, 7, 8. So it is going to be 2 and 8. It has also completed its valence shell. Okay? But this type of atoms is not a diatomic. It is CH4. So the bond formation will be such: CH1, H2, H3 and H4. Okay? This is CH4 structure. Okay, the fifth one we have studied is CH. So now what conclusion do we get from these bonding which we have seen between different types of elements of their atoms? So such bonds form by the sharing of electrons pair. So the first very thing for the covalent bond is that sharing of electron pair between two or more atoms. This is known as covalent bond. You have seen two atoms are sharing the electron, again two, again two, again two, and here 4, 1, 5 atoms are sharing the electrons. So if sharing of electron pair is there, it is called as what? Covalent bond. So in covalent bond, sharing of electrons is there. But whereas in previous we have studied about ionic bond, that was having a transfer of electrons. Okay? And the second very important thing about the covalent bond is that these covalent bonds are seen to have strong bonds with the molecules. Okay, these are strong bonds. They are not weak like ionic bonds. Strong bonds. Okay, they are strong bonds within the molecules. Okay, but strong bond within the molecules. Okay, but if we talk about intermolecular force, that is weak. But intermolecular force is weak. Okay, intermolecular force is weak. So now because of this, that is weak intermolecular force, these covalent bonds, atoms formed by covalent bond, they have low melting point. As I have already told you that this carbon has low melting and boiling point. Low melting and boiling point. So the reason for this is that the strong bonds within the molecules, but intermolecular force is weaker. It gives rise to melting and boiling point of these low melting and boiling points. Okay. So and one more thing I would like to tell you. The fifth point about the covalent bond is that since the electrons shared between the atoms, there is a sharing of electrons. There is no transfer of electrons. If the electrons would have been transferred as we have seen in the ionic bonds, तो अगर electrons transfer होते तो मतलब क्या होता है? चार्ज का transfer अगर इलेक्ट्रॉन ट्रांसफर हो रहे थे तो चार्ज का ट्रांसफर हो रहा था, इट मींस so the transfer of charge we have already read in the electricity chapter. Transfer of charge is the conduction of electricity. So since there is no transfer of charge, only sharing is there, so they are poor conductor of electricity. Poor conductor of electricity. Okay, since the electrons are shared between atoms and no charged particles are formed, covalent bonds are generally a poor conductor of electricity. So these are the main features of the covalent bond, that is there is a sharing of electrons, the strong bonds between the molecules, but the intermolecular force is weak, and the third point is that there is a low melting and boiling point, and they are generally poor conductor of electricity. Okay, fine. So now we will study about the allotropes of carbon. Okay, so before starting I would like to tell what is allotrope. The elements of carbon, they occur in different forms. Okay, elements of carbon occurs in different form. Okay, in the same physical state. Physical state remains same. In same physical state, this is called as allotropes. Okay, so if we see the properties of an allotrope, these elements are of same atom. Okay, same element. Okay, same atoms, same elements of atoms. Sorry, same elements of atoms. Okay, and if we talk about their structure, they are structurally different forms. Okay, structurally different forms. Okay, and if we talk about the physical properties, that is okay, physical property is same physical properties. Okay, and if we talk about the state of matter, that is also same state of matter. So these are the properties of a allotropes. Same element, different structures, same physical properties, and same state of matter. So there are two very common allotropes of a carbon. If we talk about, we are going to talk about it in detail. That is the diamond and graphite. Okay. So we will be talking about diamond and graphite. It is a very common type of allotropes, very commonly known. Okay, although there are many allotropes of a carbon, but we will be discussing only about diamond and graphite. These both are very common type of, these both are very common allotropes of a carbon. So both diamond and graphite are formed by carbon atoms. They are formed by carbon atoms. Okay, this is also formed by carbon atoms. Okay, so what is the difference? Where the difference lies? The difference lies in a manner in which the carbons are bonded to one another. Okay, arrangement of carbon is different. Arrangement of carbon is different. So in case of diamond, the carbon is bounded with the four other carbons. One carbon atom is bounded with the four other carbon atoms. Okay? Suppose this is a one carbon. It is going to be bounded by four other carbon atoms. Okay, like this. In case of a diamond. Okay? And if we talk about graphite, in this graphite, the carbons are bounded by three other carbon atoms. Okay? Here, diamond 4, and in case of graphite, three other diamond atoms. Three other carbon atoms. So these diamonds are three-dimensional. Okay? Diamonds are three-dimensional. Okay? But they are, graphites are 2D, two-dimensional. Okay? And now if we talk about in graphites, each carbon is bounded with only three atoms, and they give which type of, suppose it gives like a hexagonal array. Which type of array is there? Hexagonal array, that is a 2D. Okay, hexagonal array, it gives 2D, it gives 3D. Fine. So one of these, as I told you, one of these bond in this case is a double bond, and thus the valency of the carbon is satisfied. Okay, you can see here only 1, 2, 3 is there. So any one of this carbon is going to be doubly bond. Then the valency of carbon is going to be satisfied. But in this case, 1, 2, 3, 4 are there. So the valency of carbon is being satisfied. Okay. So the graphite structure is formed by this hexagonal array, and once there is a double bond, so that the valency can be satisfied. And these carbons, they are arranged, these graphites in case of carbon, they are being arranged in a layer wise. How they are arranged? Layer wise. Okay? Suppose this graphite, one is there, other, third, fourth, like a layer they are arranged. Okay? So these two difference between the diamond and graphites which is going to occur. So because of this, they are having very different physical properties, even though their chemical properties are same. Their chemical properties are also same, but because of this structural difference, their physical property is different. Physical property is different, as I have already told you in the properties of allotrope. So diamond and graphite, they have different physical properties. They look differently, okay, but they have a same chemical properties. So if we talk, diamond is the hardest substance. It is hard. Diamond is very hard because it is having it is covering its all the four carbons are there. It is very tightly bond. It is hard. But if we talk about graphite, it is soft. Graphite is soft. It is hard. It is soft and slippery. They are slippery. Okay. So what happens? Now if you see this structure, since they are tightly bound all the four, there is no free electron, okay, to be conducted. So they are the poor conductor of heat. You all know that mostly all the non-metals like carbon is a poor conductor of. But there is an exception in case of carbon. What happens? 1, 2, 3 electrons are there, and this one is free. It is not bounded with any of the atoms. So this electron is free to move. Okay? So there is a movement of charge. There is a flow of charge. So this is going to be a good conductor of electricity. It is a good conductor of electricity. Okay, whereas this one is a diamond is a poor conductor. Fine, diamond is a poor conductor, but these graphites are a good conductor. Okay, so these diamonds, they are synthesized by subjecting pure carbon to a very high temperature and pressure. Okay, they are being made as a pure carbon when they are synthesized at very high temperature and pressure. Okay, so these synthetic diamonds are small, but they are very good. Diamonds are small. You must have seen your mother wearing diamond rings or something. So they are small, but they are very natural. Diamonds are very good. Okay. So this was about these two allotropes, diamond and graphite. You must clearly see the difference between diamond and graphite. It is a very good and common question asked in exams. Okay? Because although being a carbon component, this graphite is a good conductor of heat. This is a very good thing to remember. So there is one more type of electrotrope that was identified, which is C60. Okay, this was identified very later on, but the first one to be identified was C60, which has carbon atoms arranged. The carbon atoms are arranged just like a football. Okay, how the carbon atoms are arranged? Like a football, excuse me. So since they look like football types, their structure is. This was who invented it? I would like to tell you. There was a US architect who invented it. That the name of that US architect was Mr. Fleur. Okay, he was an US architect. Okay, US based architect he was. Okay, bulk Mr. Fleur. So this molecule was named on his name as Fleur's. Okay. Fine.
good.